Tree. A tree is a non-linear data structure used for hierarchical organization of data. That is, if you have data of this kind, a parent is there, this parent is having two children, then each of those children are further having two children. This kind of data is called hierarchical data. That is, it is organized in different levels. In order to represent these sort of data in which there is a parent, then two others are originating from it, then there are further children from those children. This sort of data, whenever you want to represent, you use tree data structure. Why is this called a tree? Because it resembles a tree in real world. So let us see how does it look like. In real world, a tree will have a root. It will originate from the root. It will grow upwards. And whenever this tree want to branch out, it will again branch out upwards. This is how normally a tree is grown in real world. But coming to a data structure tree, it always grows downwards. The whatever is on top, this is the root. So root is on top and the tree will branch out and grow downwards. This is how the data structure tree is normally represented. So let us understand each of the elements in this data structure. So first thing you have to understand is node. What is a node? Each of these elements in this data structure, these are called as nodes. Each of these are nodes. What will a node contain? A node will contain data and references to its children. So what is data? Each of this node can contain some value. Let us say this is 10. This is having some value, let's say 12. This is having maybe 7. So each of the nodes can contain some value. Let us say this is 11. This is 5. This is 4. And let us say this is 15. Each of the node is having some value. And what are the references? Each node will have references to its children. So 10 will have references to 12 and 7. Similarly, the node 12, it will have references to 11 and 5. So these references are similar to the references you saw in linked list lectures. For example, if there is a linked list, in each node in the linked list will have a reference to the next node. That node will again have a reference to the next node. Similarly, in the tree, each node will have reference to its children. So you understood what is a node. The next concept is of root node. Root node is a node on top. This is called as root node. The speciality of root node is that root node will not have any parent. This will be the top node. Take any other node in this tree, they'll have some other node as the parent. If you take node 4, 7 is the parent. If you take node 7, 10 is the parent. But root node will not have any parent. The other one is of child node and parent node. Any node which is originating from another node, that is a child node. For example, 12 is 10th child. 7 is also 10th child. Similarly, 12 is also a parent. 12 is parent of 11 and 5. So, whichever is the parent from it, whatever is originating, that is called a child. Then let us also understand about leaf nodes. Leaf nodes are the nodes at the lowest level. So these are the leaf nodes. The speciality of leaf node is they won't have any children. All other nodes will be having some other node as its child. But leaf node will not have any children. So if a node is not having any parent, it is called root node. If a node is not having any children, it is called a leaf node. Okay. Then let us understand about subtrees. What are subtrees? A part of this tree which in itself is a tree, that is a subtree. For example, if you take this part, this independently is a tree, but this is a part of this larger tree. Then it is called a subtree. So this part, it holds a tree structure, but this is also a part of this larger tree. So it is a subtree. So any part of a tree is a subtree. For example, this part is a subtree. So this is the concept of subtrees. And what are edges? Edges are the links, connection between any two nodes. For example, this is edge between 10 and 7. Okay. Similarly, this is edge between 10 and 12. So all the connections between any two nodes, those are called as edges. So this is very basic terminology about a tree. You also need to understand some special properties. For example, a tree has a rule called one path rule. That is, you try to go from any node to any other node, there will only be one path possible in a tree. So let us say I want to go from 10 to 4. What is the path possible? The only possible path is to go from 10 to 7 and from 7 to 4. So the only path is this: from 10 you have to move to 7 and then to 4. So take any two nodes in a tree, there will only be one path, a unique path from the first node to the second node between any two nodes. So that is why this is a peculiar property called one path rule. Next thing, so first property is only one path. The second property is that always a tree is acyclic. What is acyclic? No part of a tree will form a cycle. Imagine there was one link between these two. What will happen then? Then there will be a cycle between 12, 11 and 5. But because this is a tree, you can never have a situation of a cycle. So it will never happen that any 3, 4 or 5 nodes or any number of nodes will never form a cycle. It will always be a acyclic structure. Okay, a tree will always be acyclic. So the third property is that tree will always be organized in different levels. So whatever is the top level, this is called level 0, this is level 1, this is level 2. This is how any tree will be organized. Then let us also understand about height along with level. So height is the property of a tree. So each of these levels, this is level 0, level 1, level 2. Height is the length of the longest path from root to any leaf. So if you see this tree, the height of this tree is 2. Why is the height 2? Because you take any path from root to any of the leaves. Maximum distance you have to travel is 2. 1, 2. Maximum number of links you have to cross while going from root to leaf. That is what is called as height of the tree. So this is basic about trees. And what are the applications? Where do you generally use trees? One is, we already discussed, whenever you want to have hierarchical data representations, then it is sometimes used for some search operations, and it is also used for expression passing and so on. So we'll see all those uses whenever we get into those lectures. In detail, we'll see how tree can be used for each of those purposes. And what else is remaining about trees? Maybe you should also know about depth. So similar to the way we understood about height, we also talk about depth. What is the difference between these? Height is always a property of a tree. So this tree is of height 2. But each of the nodes will have a property called depth. For example, this node 12 is at depth 1 because from the root till that node you have to only cross one link. The depth of this node 5 is 2. So it is similar to height, but it is a property of the node. But the height is the property of the tree. This is the difference. Then whichever are the nodes which are above, higher in the levels, those are called as ancestor nodes. And whatever are in the lower levels are called descendants. And whatever are in the same levels, they are called siblings. For example, 11, 5, 4, 15, these are siblings. 12 and 7 are siblings. So basically, siblings means from the same parent. Sorry, 11, 5, 4 and 15 are not siblings. If they have to be siblings, they have to be from the same parent. So 11 and 5 are siblings, 4 and 15 are siblings because parents are different for them. So this is about siblings, and before we end this lecture, let us slightly discuss about basic operations. Basic operations on trees. One is, if you want to create a tree, you can create node by node. How do you create? How do you insert nodes? Similarly, how do you delete nodes from a tree? And coming to trees, traversal is very important. There are different techniques used to traverse through the tree. So we'll learn about all those. There is depth first traversal, there is breadth first traversal, and inside each of these there are further classifications: in order, pre-order, post-order, so on. So in the coming lectures in detail, we'll go through all those, how to traverse through the tree, what are the different operations, and what all are the specific use cases of trees.